So here's a little explanation of how scientific notation works, just in case you're wondering, like, why does this work out the way it does? So, we have this scientific notation. We know that 1.2 times 10 to the fifth, if you, so you'd count out one and then four more zeros, you end up with this number. So how does that actually work? Like, why does that, why do they equate to each other? And so the key here is is your exponent, okay? So if I have 10 to the fifth power, okay, that equals 10 times 10 times 10 times 10 times 10, right? So, because if you have 2 squared, it's 2 times 2. If I have 3 cubed, it's 3 times 3 times 3, right? So 10 to any power is just 10 that number of times, 1, 2, 3, 4, 5. So if you actually would multiply this out, you're going to get 1, 1, 2, 3, 4, 5 zeros, right? If you would use your calculator, right? So this, the coefficient times the exponent is really, it's really 1.2 times 100,000. You can think of it that way. So this is really saying you literally take 1.2, multiply it by 10 to the fifth, or 100,000, and what's that going to give you? 1, 2, right? So that's how it works. This is sort of, you can almost take this literally. You're multiplying it times an exponent. And the same thing goes for the negative exponent, which is just on the denominator. So a negative power, you divide it by that number of 10. So 1.2 times 10, just do this quickly, 1.2 times 10 to the minus fifth. Okay, so this is 10 to the minus fifth. This part is 1 over 10. Well, we know it's 10 to the fifth, so it's going to be this. So that's the same thing as saying 1.2 times 1/100,000th, which is going to be 0.00001, which is going to give you the same answer. So 1.2 times 10 to the minus fifth is going to be 0.0000012. Okay, so that's how the scientific notation works. That's how it makes sense.